Mesdames et messieurs, j'ai l'immense honneur d'être devant vous pour vous présenter la mission AfriSAR. Et dans le futur, sur les satellites.
Which is, so we're gonna go all the way here.
Right there.
Perfect.
We're trying to understand the global carbon cycle, and we're trying to understand climate change and the effect that climate change might have on our planet in the future.
The main question we're trying to answer here is how much carbon is stored in forest ecosystems. We understand very well what's happening in the atmosphere, in the oceans, but not so much in forested sites.
And when it comes to forest structure in particular, there is a huge hole over Africa. We don't have the data that we need anywhere in Africa.
The one element that's missing is us being able to map the vertical structure of forests. When you look at an image, you can tell there's forest there, you can tell it's green, but we don't know how tall it is. If we can tell how tall it is, then that's a very good proxy for how much it weighs, and with that you can infer biomass, and with that you can infer carbon.
NASA has a few upcoming missions to look at this, and so does the European Space Agency. We have lots of different things we're putting in space, but one of the main goals of all of these missions is to count how much carbon is stored in the Earth's forests. So how we do that is essentially measure how big the trees are. Especially here in the tropics, most of the carbon is stored in the tree trunks and above the ground. So we're measuring how fat the trees are, how tall they are, and then comparing that to our spaceborne measurements.
51.3.
The picture is degraded, but it shows the carbon cycling of the forest. The sun and the light would actually shine on these forests, and they absorb the carbon from the atmosphere, from the photosynthetic activities, and they grow. So as the forest grows, we capture more carbon from the atmosphere. So the forests are extremely important for global carbon cycle and climate change, because by having the forest, we mitigate part of the carbon we put in the atmosphere from our cars and our factories.
There is a very big effort to integrate the remote sensing imagery with ground data. What we can get from remote sensing is the vertical structure of the forest, but we need people on the ground to tie that information to biomass. The biomass is what we're really after. And with ground plots, we can make that connection between a height in a particular plot and the biomass.
So when we are looking at the forest, we're very much interested in this trip to look at the structure of the forest. The trees have irregular shape, but the volume of the trees and the size of the trees is extremely important for us, because that tells us what would be the mass of the forest. So if we measure the diameter of the trees and tree height and know the wood density of the trees, we get an estimate of the mass of the tree. And almost half of the mass is carbon. So by measuring the size, we actually get an estimate of the carbon in the forest. And that helps us a lot to use our measurements from the airborne sensors and from the satellites to calibrate with that carbon on the ground.
The mangroves in Gabon are one of the tallest mangroves in the world. We are interested to know how the water circulates within this ecosystem, how it comes in and out of the system. So once we understand the hydrology of these systems, it helps us also understand how these ecosystems really work and what drives their productivity. These mangroves are some of the most productive ecosystems on Earth. They stock huge amount of carbon, of which most of it is located and captured in the soils. The advantage of the airborne campaign over any other observations like spaceborne observations is with airborne you can go wherever you want, whenever you want. You can have almost real-time and designated campaign just to observe a given phenomenon. Like this one here, which is a mangrove ecosystem. What happens in these systems which are driven by hydrology is that you have tidal impact that comes in and out of these ecosystems twice a day. It's extremely dynamic.
So you see where the roots are dark, that's how high the tide goes.
And you can only monitor these kind of ecosystems with airborne sensors. The spaceborne sensors have repeat past periods in the order of weeks to months. So the airborne campaign is optimum for that. In particular, the UAVSAR, we're not only using to try to estimate forest canopy height, but we're also developing this new technique whereby we can measure water level with repeat pass interferometry. So we cover the same area during a full tidal cycle as the water rises and retreats from the ecosystem. And the UAVSAR can actually give you this sort of measurement. We'll be able to measure the relative change in height of the water within those ecosystems. And here we're setting up probes in these systems that will be used in the validation of the data sets and the measurement from UAVSAR.
We use these data to get a feeling for what the radar images, the final product is going to look like. And we also provide these images to researchers on the ground so they can decide where to go to do their field work. This is a region that's very hard to do field work at, so the researchers have to be smart about deciding a place to establish their field plots. We want to map forest biomass globally, and the ultimate goal is to tie that in to the carbon cycles. It's important to understand how that changes in space and in time, because this will have consequences for management and policy. And in order to do that, we need to see what the biomass is in different places of the world and how forests respond to changes in climate and changes in management.
And now that we're very interested in doing carbon accounting, we've also found that mangroves store large amounts of carbon, not only in the trees. I mean, these trees here in Gabon are huge, so they have a lot of carbon in their trunks, in their above ground biomass, but there's also a lot of carbon that's stored in the soils here. It's really, I think, important to be able to try to account for that so that we can continue protecting them and just get a better understanding of these ecosystems.